Hello, and welcome to the presentation on the Ecoroof initiative for climate change resiliency. My name is Kelly Learned. I'm a project manager with Mistakis. I'm presenting on behalf of my colleagues at Mistakis, as well as Ecoroof team members, Dr. Brad Bass from the University of Toronto, and he's also the in-house green roof expert at Environment Canada. Also on our team is Carrie Ross. She's our technical project advisor of Green Tea Design in Calgary. Also joining me today is Danielle Koliak, Environmental Project Manager with the City of Edmonton.
Hi, everyone.
This research project is a partnership between the Mistakis Institute and the City of Edmonton. To start the presentation, we'll provide a quick introduction to who Mistakis is. Then Danielle will speak about the Edmonton climate strategy and introduce the Ecoroof project. From there, we will present findings from the jurisdictional review and function report we completed over the last year. Then we will end the presentation with an overview of the research advisory group process. So let's get started. Mistakis Institute is a not-for-profit environmental research institute based out of Mount Royal University in Calgary. Our job is to get science and information into the hands of decision makers related to land conservation and environmental stewardship. Most of our work is supported by philanthropic dollars through grants. We continually work in partnership with other organizations and all levels of government, such as the City of Edmonton. So I'd just like to take a moment to thank our supporters of this project. We have funding support provided by the City of Edmonton, the Edmonton Community Foundation, Alberta Eco Trust, and the Federation of Canadian Municipalities. And now I'm going to hand it over to Danielle to give us a little bit more information about Climate Resilient Edmonton and the Ecoroof project itself. Danielle?
Thank you, Kelly. So the next few slides that I will present on are really to provide everyone with the context around the City of Edmonton's approach to climate change adaptation and resilience. So cities around the world are addressing climate change in two ways. First, cities are taking actions to reduce greenhouse gas emissions that cause climate change, and these are referred to as mitigation actions. For the City of Edmonton, our Community Energy Transition Strategy and our Corporate Greenhouse Gas Management Plan provide Edmonton's mitigation approach. The second approach that this Ecoroof and Climate Resilience Initiative is really aligned to is adaptation. And adaptation is all about preparing for and responding to the impacts climate change may have on our community. Adaptation is important for ensuring that Edmonton can respond to climate change in a way that protects our people, our infrastructure, our economy, and our overall quality of life. So Climate Resilient Edmonton Adaptation Strategy and Action Plan was presented to City Council in 2018, and it puts forward a path for Edmonton to become more resilient and adapt to climate change. To develop Climate Resilient Edmonton, we took a multidisciplinary stakeholder-led approach. The strategy was developed over a 3-year period in consultation with a stakeholder advisory group that was together for the entire duration of the project. And this comprehensive plan looked at a variety of climate change indicators and their potential impact on a spectrum of assets and service areas. Everything from our engineered infrastructure, such as buildings, our transportation systems, water treatment systems, etc., to things like the economy, our natural environment, and then also to our social systems, such as community and culture and public health and safety. And in general, the primary climate change risks identified that Edmonton should prepare for are changing temperatures, and in particular, increasing temperatures. And this could include temperatures that we've never really experienced very often here in the past. I do want to stress, however, that while we are expecting hotter temperatures, we should still be prepared for cold temperatures. We just might not experience them as often as we're used to, and they might not be as cold as they used to be. Our changing precipitation patterns are also expected, and mostly we're looking at drier summers, wetter winters overall, and more extreme precipitation events. So those short duration, high intensity rainstorms that can contribute to things like urban flooding. We also need to be prepared for more variable and frequent extreme weather events. So those things such as convective storms that can bring lightning and hail, wildfire conditions, events like that. And as well, Edmonton is expected to experience a long-term shift to an overall warmer and drier climate. And this could lead to changes in the types of ecosystems that our region can support. So the next couple of slides, I'm going to go over a couple of these climate changes and examples of the impacts those changes that Edmonton needs to prepare for. So changing temperatures. Extreme heat and increasing temperatures can have several negative impacts, including heat stress on both our built and our natural infrastructure and environments. But another important impact of extreme temperatures is the impact on human health, as more extreme heat events and heat waves contribute to an increase in heat-related illnesses, especially for vulnerable groups of people such as the elderly, sick, or children, or people who don't have access to air conditioning or other types of cooling amenities. This can be worrisome in climates like Edmonton, where we have not typically had to deal with this in the past, and therefore we might not be as prepared for these events. Changing precipitation patterns can also impact Edmonton. More extreme rain events can contribute to urban flooding, as I mentioned, and flooding, of course, has impacts on our built infrastructure, but also physical and mental health impacts on people affected by it. More rain events in the winter, such as freezing rain or rain on snow, can have human health impacts from slips, trips, and falls in the icier conditions, and it can also impact our recreation activities. And of course, the flip side of this is also the potential for longer and more severe drought conditions, which we are expected to have in Edmonton. And this can have human and environmental impacts. In severe enough droughts, it can cause damage to our forest canopy, and it can even cause issues with underground pipes and building foundations. As well, drought conditions can have economic impacts, especially in agricultural regions such that Edmonton is in. So these climate changes and associated impacts I have just presented represent only a few examples of climate change in Edmonton. Climate Resilient Edmonton lays forward a path to help Edmonton adapt and become more resilient to these climate changes. One of the foundational elements of our strategy is a pathway centered around evidence and science-based policy and decision-making. So by conducting the type of exploratory research that we are doing in this Ecoroof project, we will hopefully become better informed and have the right information when it comes time to developing programming around this type of intervention. So one of the specific actions identified in the path towards resilience, among many, is to research and evaluate the potential for green roof implementation in Edmonton, as green roofs can be one tool to help Edmonton mitigate some of these climate change impacts. So as mentioned, this project is really about conducting that exploratory research on potential Ecoroof program considerations in Edmonton. This project is being conducted through a combination of primary literature review, best practice and jurisdictional reviews, and through engaging stakeholders and knowledge holders such as yourselves on the research. So I will now hand it back over to Kelly to go through some of the more specifics of this project. Thank you.
Great, thanks, Danielle. Before I get into some of the details of the research and reporting that we've done to date, I just wanted to give a quick overview about what an eco-roof is. So an eco-roof can also be referred to as a green roof, vegetated roof, rooftop garden, or a living roof. And there are two types of eco-roof systems that are typically built. An extensive roof is a lightweight, sometimes non-accessible for public or other members of that live in the building. And they also have a shallow substrate or soil to support plant growth. Plantings are usually things like grasses, sedums, flowers, and other low-growing plants. The extensive roofs are typically used on buildings where there may be structural constraints, such as on an existing building that wasn't purpose-designed for an eco-roof. Then there are the intensive roofs that are able to support heavier weight and can be designed for a rooftop park or garden. Intensive roofs are typically accessible by building users. So whether it's a lightweight extensive roof or an intensive roof, there are several elements that are required, and these are listed on the slide here. We'll talk about benefits in the next few slides, but it's important to understand the challenges that are associated with the eco-roof installation. Initial cost is higher, but over the lifetime of an eco-roof, studies have shown cost savings related to stormwater management, building energy use for cooling and heating, and lifespan of the roof, in which the roof life can be extended for up to 30 years or more than a traditional roof. Eco-roof designers are often asked whether a roof can handle the extra load of the eco-roof when you factor in snow load in our area. Before an eco-roof is designed, loading capacity must be determined. Design solutions could be that a retrofit is an extensive roof instead of an intensive roof, the one with thicker soils and more substantial plantings and things like that. Another design consideration is the microclimate on a roof. Not all rooftops are the same. Sun and wind exposure due to adjacent buildings are key considerations as well. Having an experienced Ecoroof installation crew is another important factor to consider, as leak prevention is one of the key challenges of Ecoroofs. Ensuring maintenance costs and approaches are factored into the Ecoroof project from the beginning are a good practice for ensuring a successful project. So the question is, why study Ecoroofs in the context of climate resiliency? If you think about it, before downtown Edmonton existed, the area was a natural landscape. Urban development has changed the area from a vegetated, cooling ecosystem to one of non-permeable, non-vegetated, hot surfaces. Otherwise unused building rooftops can be transformed into eco-roofs and provide the opportunity to replace some of what was lost during development in urban areas. And urban areas typically have limited space available for things like parks, green space, and vegetation at ground level due to densification, roads, and other urban infrastructure needs. Eco-roofs are also considered by a lot of jurisdictions as a no-regrets climate adaptation measure because they provide a multitude of societal benefits. So while our research focused on the environmental benefits, it is important to note that there are numerous economic, amenity, health, and well-being benefits, such as job creation, improved quality of life from a view of a green space, and environmental improvement as well. Studies have shown that when employees have a view to nature or something green, there are less sick days reported and productivity tends to increase. As well, studies conducted in hospitals have shown quicker recovery times when patients have access to or a view of green space. This highlights a few of the potential co-benefits from eco-roofs. Next, we're going to speak to some of the policy findings gathered as part of this project. When we first started the Ecoroof project, because we were partnering with the municipality on the research, we wanted to understand why other municipalities embarked on Ecoroof programs and see if there were tangible impacts or benefits derived. First, we did a desktop scan of existing Ecoroof policy programs and created an inventory of what we found. Then we reached out to a number of the municipalities to see if there would be someone that could be interviewed on the key motivators for their program, provide some insight into any challenges they experienced, what kind of impacts were realized through the program, and any key lessons learned that they had to offer. We were able to connect directly with 4 municipalities and have reported the results in an Ecoroof jurisdictional review report on the Mestakas website. The Mestakas website address will be provided at the end of the presentation for you. We also made notes on several European examples as well because they were well ahead of North America in terms of green roof or eco-roof policy and incentive programs. I'm going to share highlights from 2 of the municipalities that we interviewed. The first is Toronto. They report on a number of impacts from their Ecoroof program, which includes things like stormwater diverted, kilowatt hours of energy per year saved, greenhouse gases avoided, and new employment. So as you can see on this slide, they've also calculated dollar estimates related to some of the impact areas. And in 2016, they estimated they saved over $200,000 for that year for the municipality. The City of Portland had an incentive program for 4 years, and it supported over 130 projects by providing close to $2 million in incentives. The focus of their program was in stormwater retention, and they calculate approximately 16.7 million liters of stormwater are captured and absorbed each year. And they have also noted anecdotally that an eco-roof industry has emerged as a result of the 4-year program, and eco-roofs continue to be built in their city. So that's a quick snapshot of the jurisdictional report. Again, if you're interested in reading a little bit more about this, the findings in this report, it'll be on our Mestakas website. Using the jurisdictional review, we used some of the key motivator findings from the study to direct what we would focus on in terms of function research. We asked ourselves, how do eco-roofs impact the function of an area of interest? For example, how do eco-roofs affect stormwater retention in urban areas? What kinds of factors need to be considered? And what amount of impact was reported? We also tried to focus on study locations that might be similar to Edmonton's context. We began this research in the fall of 2018 and completed it in March of 2019. The full and detailed report can be found on the Mistakis website. Today, we're going to provide just a high-level overview of the findings on how ecoroofs impact the function areas and illustrate with a few study examples. Starting with the function area of urban heat island effect. Just for a bit of background, as urban areas develop, and as I mentioned previously, what was once natural landscape is replaced with impermeable surfaces that absorb incoming solar energy and convert it to heat. So this increases surface temperatures of the roof and surrounding air temperatures. And as this graph shows, urban temperatures can be elevated in comparison to more suburban or rural areas, and it's called the urban heat island effect. Many cities are working to address this as changes in climate are expected to elevate annual temperatures and potentially cause a variety of environmental and health problems with economic consequences, as Danielle pointed out in the Edmonton climate work. An example that we found was from Toronto, and they did some scenarios. So one of their scenarios was, what if we added Ecoroof to 50% of the available surfaces in our downtown area? And what they found is that by doing that, they would cool the entire city by 0.1 degrees Celsius to 0.8 degrees Celsius. And then they also took that a step further, and they found that irrigating these roofs could further reduce temperatures by about 2 degrees Celsius and extend a 0.5 degrees Celsius to 1 degree cooled area over a larger geographic region. So not only did the Ecoroofs have an impact on the area where they assumed they would be located, but it extended beyond that as well. Traditional roofs absorb solar radiation and increase the roof surface temperature. Thereby, this increases the temperature of the building below. So the insulation provided by Ecoroofs paired with the reduced roof surface temperature reduces the amount of energy required to cool the building. As an example, from a study done on the thermal performance of green roofs in cold climates demonstrates energy savings of between 10% and 20% of the total heating energy used over the winter months was realized on the Ecoroof that they were studying. This study also concluded that more savings would be possible when considering summer cooling needs. But because this was done for cold climate research purposes, they did not extend their research to summer. One more example we wanted to share with you, our colleague Dr. Brad Bass was involved in this study, and it is of a Walmart in Chicago. Findings from this study showed a 6 to 10% energy cost savings, as well as peak demand reduction in energy. It's noted that this is likely due to an Ecoroof's ability to stabilize the roof temperature rather than have highly fluctuating temperatures throughout the day, as shown on traditional or white roofs. And as this slide shows, a significant annual cost savings could be realized from a full Ecoroof install. And the translation into Canadian dollars was between $8,000 and $24,000 savings annually for a full Ecoroof. Stormwater retention. An interesting fact that we found was that most urban centers' non-permeable surfaces are between 30 and 50% rooftops. As a city becomes more dense, that percentage will increase. Ecoroofs can add capacity to the traditional stormwater system, which is often at capacity in existing urban centers, and Ecoroofs do this by slowing down and absorbing stormwater during rain events. One study conducted by our colleague Carrie Ross in Calgary showed retention capacity of up to 66% throughout the year, and higher retention up to 99% in the drier summer months when the roof is less saturated. The Department of Energy in the United States has done extensive studies on Ecoroofs, and they stated in one of their studies that a typical roof, so the more extensive lightweight roofs, could store up to 75% of the annual precipitation that fell on it. This would, however, vary depending on the time of year. The study also stated that these findings would be applicable to most jurisdictions throughout the United States. Lag time is also important to assess the existing stormwater system, especially with more extreme weather expected in the coming years. So lag time is when an Ecoroof slows down water being released into the storm system. And in a Toronto study, lag time was recorded up to 40 minutes after a rain event. Often, habitat above ground in urban areas is not considered as an option, but eco-roofs are being designed and studied to understand whether they do offer habitat for certain species of insects and birds. In the past, typical eco-roofs were planted with sedum, but designers are now branching out to plant more diverse plant species as well. Studies out of Europe that we found indicate there is a potential for habitat creation on eco-roofs for certain types of species. For example, roof species surveys in Switzerland found that 10% of the beetles observed were considered threatened, and 40% of the spiders were considered rare. Policymakers are also looking to eco-roofs as good opportunities for pollinator pathways and bee habitat. Air quality plays a major role in human and ecosystem health, especially in the urban environment where pollutants can be heavily concentrated and the urban heat island effect can occur. As you likely know, vegetation removes contaminants from the air. Installing vegetation on a rooftop provides an opportunity to improve air quality and have a positive effect on the health and well being of those in the area. We found one report by Green Plants for Green Buildings that estimates that a 1,000 square foot eco roof can remove about 40 pounds of particulate matter from the air in a year, while also producing oxygen and removing carbon dioxide from the atmosphere. So, to give you a sense of what 40 pounds of particulate matter is, it's roughly equivalent to how much 15 passenger cars will emit in a year of typical driving. Another study that we found was based in Washington, and they completed scenario modeling to demonstrate the potential impact of installing eco roofs on 20% of total roof surface area available at a certain size. The results of this projected were comparable to the amount of pollutants that could be absorbed by, and this always blows my mind a little bit, 25,000 to 33,000 street trees. And this is a significant finding given the limited amount of space available at ground level in urban contexts. This was a brief overview of how eco-roofs impact the function areas of interest from an environmental perspective. And as I mentioned earlier, there's a report posted on our website if you're interested. I also mentioned earlier in the presentation the social and economic benefits of eco-roofs can potentially provide and include things like noise reduction because eco-roofs provide additional insulation on a building. Urban agriculture is also a possibility with eco-roofs, as well as access to open space. Although who has access to the space definitely depends on the building and what it was built for. Other benefits include the previous mentioned job creation from a new industry, as well as increases in property values with a view of or access to a green roof. Overall aesthetics and quality of life improvements can be associated with eco-roof development. Even though there are numerous benefits that can be cited in relation to eco-roofs, the scale of the benefit or impact depends on a number of factors. Having a critical mass in close proximity would have a different impact than the same amount of area dispersed over an entire city. What I just mentioned relates to location. Critical mass versus a dispersion of eco-roofs affects the amount of impact. Type of eco-roofs installed means that research shows that the deeper the substrate or soil on an eco-roof translates to higher stormwater retention, higher building energy efficiency, and opportunity to create more biodiversity. However, weight is an essential consideration. So while lighter weight and therefore shallower soil depths may not have the maximum benefit, they do still benefit substantially when you compare it to a traditional roof, where there is relatively no environmental or social benefit realized. And finally, what the roof is designed for influences the type of impact the roof will have. Is the roof designed to maximize stormwater retention? If so, can that also benefit habitat and biodiversity in some way, or will that not be possible? The potential benefits, scale of impact, and type of impact, alongside the challenges and barriers to eco-roof development, are all considerations for any municipality exploring eco-roof possibilities. What has been revealed is that eco-roofs do have a positive impact on the environment, and that is why we're excited to continue this discussion with you, the stakeholders, to further explore the potential for eco-roofs in the Edmonton context. To wrap up the presentation today, I'd like to provide an overview of the process we're embarking on as a project team. If you're watching this presentation, you have likely been invited to participate as a research advisory group member for the Ecoroof research project and have received a summary of the process. We will be conducting stakeholder interviews in April and May. These interviews are a one-on-one conversation with a Mistaka staff member to provide a brief overview of the research project and how the City of Edmonton is involved as a research partner. We will ask a set of questions relating to the project purpose, to understand your organization's mandate, your organization's level of interest and/or knowledge of Ecoroof technology and policy. We'd also like to hear any key questions you hope to get answered in the process. We will also ask you who you think is essential to be at the table for this engagement. After the interviews, we'll be distributing a short survey to all participants to gain an understanding of challenges and opportunities related to eco-roofs in the Edmonton context. A survey summary and report will be provided to everyone and posted on our website. All answers will be anonymous in the reporting. The stakeholder interviews and the online survey will help us design and develop the best questions for the workshop, so that not only will we dig deeper into some of the most relevant issues according to you, we also want to make sure we're making the best use of your time. On May 28th, we're planning to get everyone together to have discussions in person. We're really looking forward to an informative, enlightening session with you, so please mark this on your calendar and we will send the logistics and details closer to the date. If we are able to find a location in close proximity to an eco-roof, we'll also offer a tour of the roof as part of the workshop, so stay tuned on this. Once the engagement items are completed, Mistakis will develop a workshop report for distribution to stakeholders. This report will highlight a set of recommendations about the potential and challenges to consider if the city decides to explore an eco-roof policy program as part of the climate change strategy for Edmonton. We look forward to having you joining us in this process. Thank you so much for taking time for this presentation on the Ecoroof Initiative for Climate Resiliency. If you have any questions, suggestions, comments, please do not hesitate to reach out to either myself or to Danielle, and our email addresses are listed on this slide here. As promised, all the reports completed to date can be found on the Mistakis website. When you go to our homepage, which is www.rockies.ca, click on What We Do in the title bar. Then go to the research areas. Next, you'll find Municipalities and Conservation. Click on that. Once you're on that page, you scroll through the boxes until you see the Edmonton Ecoroof and Climate Change Resiliency Initiative. Quite a mouthful there. Any problems finding the information, please contact me and I will walk you through the clicks. So again, thank you for your time. We really look forward to seeing you on May 28th. Bye.